6.2 goes over multiplication and division using rational expressions. So with your multiplication, you got to remember multiplying fractions. It's the same exact concept. You can multiply straight across and then reduce if you can, or you can cross simplify before you multiply. It is totally up to you. You will have to factor with these as well, so you got to keep that in mind also. If we look at example 1, it just tells us to find the product. For A, we're given 3a to the 8th power b cubed over 6b times 10a over a squared b to the 6th power. So again, you could simplify before you multiply, or you can multiply straight across first and then simplify. If I multiply straight across first for this one, the 3 times 10 is 30. The a to the 8th power times a is a to the 9th power, and then I have b cubed. On the bottom, that's 6 multiplies with a 1, so that's 6. And then I have a squared. B times b to the 6th is b to the 7th. So again, you're keeping in mind your rules of exponents when you're multiplying these. If the base is the same, add the exponents. And now from here, we're going to reduce. If you see, I've kind of kept this as one fraction, but separated each part, so my constants or the coefficients are over each other, my a terms are over each other, my b terms are over each other. To me, it makes my life a little easier when I do this, so I can visually see what my like terms are that I can reduce with. So that 30 and that 6 can simplify by dividing both of them by 6. The 6 would become a 1, the 30 is a 5. The a to the 9th power over a squared, we're going to subtract 2 from 9 to get a to the 7th power. That b cubed over b to the 7th power, your bigger power is on the bottom, so it's going to stay on the bottom, and you're going to subtract those two powers. So the top one cancels out, and we'll subtract 3 from the power of 7 on the bottom. So this is simplifying to be 5a to the 7th power over b to the 4th power. And again, you could have simplified this before you multiplied it. If you did that, the 3 would become a 1, the 6 can become a 2, the 2 and the 10 can simplify, the 10 would become a 5, the 2 would become a 1. From there, your b's on the first fraction can simplify, just become b squared, and then they can simplify with the 2 and the 6, so the 2 would cancel out and you would subtract the 2 from the 6. The second fraction, your a, would cancel out the a squared on the bottom, and then you get your a on the bottom. The first fraction will cancel out the 8 to make it a 7 on the top of the first. So again, you could do that. It makes things a little bit more complicated, so you got to keep reminding yourself of the different parts, or again, you could just multiply straight across like we did and then simplify. For example B, Example B gives us x squared plus 7x plus 12 over x squared plus 3x times x squared over x squared minus 16. We are going to factor every single part of these two fractions that we can in order to simplify before we multiply. That x squared plus 7x plus 12. Your factors of 12 that add up to be 7 are 3 and 4. So this factors out to be x plus 3 times x plus 4. On the bottom of this fraction, you have x squared plus 3x. They both have an x, so factor out the greatest common factor, which is x. You have x times x plus 3 left over. For the second fraction, you have x squared in the numerator. You cannot simplify that or factor that, so leave it the x squared in the numerator. On the bottom, you have a difference of squares, so that factors out to be x minus 4 times x plus 4. Again, if you want to simplify before you multiply, you can do so, or you can multiply straight across and then simplify. I like simplifying before I multiply, so that way I'm not multiplying out so much and then factoring and then simplifying. So with the first fraction, the x plus 3 is on the top and the bottom, so they cancel. For the first fraction numerator, second fraction denominator, they both have an x plus 4, so those cancel. Your first fraction is now 1 over x. Your second fraction is x squared over x minus 4. You can still simplify the x and the x squared since they are across from one another. The x would become 1. The x squared is just x. So from here you can multiply straight across. 1 times x is x, and 1 times x minus 4 is x minus 4. If you see, I keep parentheses around this x minus 4 because I cannot simplify this anymore. Because the x on the top does not have a minus 4 with it, it does not cancel out with the x minus 4 or the x in the denominator. That x minus 4 in the denominator is representing one single number. For example, if it told you that x is 2, if you plug in 2 anywhere you find an x, you have 2 over 2 minus 4. So that's 2 over 2 minus 4. That's a bad example. But 2 over negative 2. That's not the same thing. Okay? So you can't cancel out an x if you have an x plus a number or x minus a number underneath it. If we look at example 2, we're finding the product, but now we're working with different types of factoring. So you're going to have to think greatest common factor, not only difference of squares, but difference of cubes, sum of cubes, perfect square trinomials, that kind of thing. If we look at example A, we have x squared minus 1 times 6 over 2x squared plus 2a squared plus 4a plus 2. We're going to change this to be 2x squared, just so that way we can actually cancel out. All right, so this is going to become an x, 2x squared, 4x. Okay, so from here, we are going to factor and turn the first term into a fraction as well. So that x squared minus 1 is the difference of squares. We're going to have x minus 1 times x plus 1. We're working with fractions, so we're going to put this over 1. Second fraction, we have 6 in the numerator. It stays in the numerator. There's nothing else with it. In the denominator, you have a like factor that you can factor out of that 2x squared plus 4x plus 2. Your greatest common factor there is 2. So this is going to become 2 times x squared plus 2x plus 1. You can continue to factor the denominator of that second fraction. So I'm going to rewrite this one more time. I'm going to have x minus 1 times x plus 1 over 1 times 6 over 2 times that x squared plus 2x plus 1 is a perfect square trinomial. Your factors of 1 that add up to 2 are 1 and 1. So this is x plus 1 times x plus 1. Your 2 and your 6 of that second fraction can simplify. The 2 becomes a 1, the 6 becomes a 3. The first fraction has an x plus 1, so that cancels with the second fraction's denominator of one of the x plus 1s. From here, you only have x minus 1 over 1 times 3 over x plus 1. We will multiply this straight across. We're going to have 3 times x minus 1 over x plus 1. You can leave it in factored form, just like I'm doing here, so that way you know that you are completely simplified and you have nothing more to do with this question. For example, B, we're given a cubed minus b cubed over b minus a times 6 over 2a squared plus 2ab plus 2b squared. I'm going to do a couple things with this. First thing that I realize is the denominator of the first fraction is opposite order as the numerator. So I'm going to rearrange that and factor out a negative from there. So it's going to be negative a plus b to make it to where I know that I can factor out a negative and it becomes the same as another fraction or another set of parentheses I'm going to have. So I'm going to just rewrite this using that method first. And now I'm going to start factoring. So the top of the first fraction is a difference of cubes. Remember your difference of cubes formula. If there's a negative between the two, a minus b times a squared plus ab plus b squared. So if we take the cube root of a cubed, that's a. The cube root of b cubed is b. So we're going to have a minus b times a squared plus ab plus b squared all over. Factor out a negative from that negative a plus b. It becomes negative 1 times a minus b. Your second fraction, you have a 6 in the numerator. Keep it there. The denominator, you have 2a squared plus 2ab plus 2b squared. So we're going to factor out the greatest common factor of that, which is 2. So that's a squared plus ab plus b squared. From here, we are going to simplify before we multiply. The negative 1 and the 6 can't do anything. The 2 and the 6 can. The 2 would become a 1, the 6 becomes a 3. From there, your a squared plus ab plus b squared cancels out with the a squared plus ab plus b squared. So this all cancels out. Your a minus b on the first fraction cancels out with the a minus b below it. So that's just 1 over negative 1 times 3 over 1. The negative 1 with the first fraction gives you a negative 1. The 3 over 1 is 3. So negative 1 times 3 is just negative 3. They will not always factor out like this, but in the cases that they do, it makes your life a lot easier. For example 3, we're given m minus 4 over 3 times 6 over 4 minus m. So again, I'm going to rewrite the second fraction to be negative m plus 4, just so that way my terms are in the same order as the way they are in the first fraction. So first fraction m minus 4, I put parentheses around it, over 3. Second fraction 6 over negative m plus 4. First fraction, second fraction both have an m and a 4 in one set of parentheses. However, their signs are opposite of each other. I'm going to factor out a negative 1 from the second fraction's denominator. So this is going to give us m minus 4 over 3 times 6 over negative 1 times m minus 4. Now I can simplify before I multiply. The m minus 4 can simplify. The one on the top fraction gives me 1. The 3 and the 6 can simplify to become 1 and 2. So I just have 1 over 1 times 2 over negative 1. The 1 over 1 is 1, times 2 over negative 1 is negative 2. So that's just negative 2. All right, so the next part of your notes goes over dividing rational expressions. When you are dividing these rational expressions, you want to keep in mind that you need to factor. When you divide, you change, you flip. You want to simplify, and then you want to multiply. When we look at example 4a, we're finding each quotient of these. So with a, we're given 10 over 3x divided by 6 over 5x. You cannot factor any numerator or denominator that you have here, so keep, change, flip. The first fraction is going to stay the 10 over 3x. You'll change to multiplication, flip the second fraction, you have 5x over 6. You can simplify before you multiply. The 10 and the 6 are both divisible by 2, so the 6 turns into a 3, the 10 turns into a 5. The 3x and the 5x both have an x on them, so we are going to cancel out those x's and just multiply straight across. So 5 times 5 gives us 25, and 3 times 3 is 9. So 25 over 9 is our answer for this one. For example B, we have 5a squared b to the 8th power, all divided by, or all over c to the 3rd power, divided by 4ab cubed c. I'm just going to rewrite this to where that 4ab cubed c is a fraction, so I'm going to put it over 1. So I'm going to have 5a squared b to the 8th power over c cubed divided by 4ab cubed c over 1. From here, we're going to keep, change, flip, because we cannot factor. So this is going to give us 5a squared b to the 8th power over c cubed times 1 over 4a b cubed c. Now, with this, if you want to simplify before you multiply, you can do so. I'm just going to multiply straight across and make sure that my variables that are the same are on top of one another, so I can see if I can cancel them out at all. So again, I multiply straight across. This is going to give us 5a squared b to the 8th power over 4a b cubed c to the 4th power. Remember that c on the denominator of the second fraction has a power of 1, and we're multiplying, we add those powers. So from here, we can cancel some of these variables out. That a on the bottom would subtract 1 from the 2 in the power on a on the top. And then that b to the 8th power over b cubed, that b cubed cancels out, and we're going to subtract the 3 from the 8. So this is going to leave us with 5a b to the 5th power over 4c to the 4th power. I think, yep, that is it. All right. For our next example, for example 5, we're finding the quotient again. For a, we're given a squared minus 4 over a squared plus a minus 2 divided by 2a minus 4 all over 3a minus 3. So with these, we are going to have to factor first before we keep, change, flip. It's going to make our life so much easier if we do that. That a squared minus 4 is the difference of squares. So that factors out to be a plus 2 times a minus 2. In the denominator of that fraction, you have a squared plus a minus 2. Your factors of negative 2 that add up to be a positive 1 are negative 1 and positive 2. So this is going to be a plus 2 times a minus 1. For the second fraction, our numerator, we have 2a minus 4. Your greatest common factor between the 2a and the negative 4 is 2. So factor out a 2 to give yourself 2 times a minus 2. In the denominator of that fraction, you have 3a minus 3. Your greatest common factor there is 3. So factor out a 3. It gives you 3 times a minus 1. Now that you are completely factored in each of these fractions, keep, change, flip. Keep the first fraction the way you have it, so a plus 2 times a minus 2 all over a plus 2 times a minus 1. Change to multiplication and flip the second fraction. So 3 times a minus 1 over 2 times a minus 2. Simplify if you can before you multiply. The first fraction, you have an a plus 2 on the top and the bottom, so they cancel out. On the first fraction in the numerator, you have a minus 2. Across from that, you have an a minus 2 in the denominator, so those cancel out. In the denominator of your first fraction, you have an a minus 1. Diagonal from that in the numerator of the second fraction, you have an a minus 1, so those cancel out. So this leaves you with 1 over 1 times 3 over 2. We multiply straight across, and we are just left with 3 over 2. For example B, we are given 25 minus x squared over x squared plus x divided by x minus 5 over x squared minus 1. The numerator of that first fraction, you have 25 minus x squared. Your x squared does not come first there, so I'm going to start this one by rewriting it as negative x squared plus 25 over x squared plus x divided by x minus 5 over x squared minus 1. From here, the top fraction, or the top of the first fraction, we can factor out a negative 1. It leaves us with x squared minus 25. The bottom, we can factor out an x. It gives us x times x plus 1. The top of the second fraction, you're going to leave as x minus 5. The bottom, you have a difference of squares, so it's x minus 1 times x plus 1. You can still factor the top of the first fraction because you have a difference of squares with that x squared minus 25. So with that, keep factoring, you get negative 1 times x minus 5 times x plus 5. Keep it over the x times x plus 1. If you want to keep change flip at this time as well, you can do so. It would just turn into multiplication, and you would have x minus 1 times x plus 1 over x minus 5. From here, you can simplify before you multiply. Diagonally, the x minus 5 is in the numerator of the first fraction and the denominator of the second fraction, so they can cancel. Diagonally, those x plus 1s are in the denominator of the first fraction and the numerator of the second fraction, so they cancel out. From here, we just have negative 1 times x plus 5 over x times x minus 1 over 1. So if we multiply straight across here, we're going to have negative 1 times x plus 5 times x minus 1 all over x. For the next set of examples within this lesson, you are going to be looking at these division problems a little differently. For example 6a, we have a plus b over 3 all over 1/2. This means the same exact thing as a plus b over 3 divided by 1/2. Division and fractions mean the same exact thing. So if we keep change flip, we're going to have a plus b over 3 times 2 over 1. We cannot simplify before we multiply, so we're going to multiply straight across, and we get 2 times a plus b all over 3. For example B, we're given x squared minus 4 over 2 all over x minus 2 over 3. So again, we're just going to rewrite this as x squared minus 4 over 2 divided by x minus 2 over 3. We can factor that x squared minus 4 because it is a difference of squares. So when we rewrite this and keep change flip, we're going to have x minus 2 times x plus 2 all over 2 times 3 over x minus 2. Those x minus 2's are diagonal from one another, so they cancel out, and we can just multiply straight across. And we would have 3 times x plus 2 all over 2. For our last example within this lesson, we are given m squared plus 1 over 5 all over 3. So this just means m squared plus 1 over 5 divided by 3, or 3 over 1. If we keep change flip, we have m squared plus 1 over 5 times 1 over 3. So we multiply straight across. Anything times 1 is itself, so we can just do m squared plus 1 all over 5 times 3 is 15.